The next topic we can have a look into now, since we already know how to create a grid, we know how to create points or the snapping references for all the members that we're going to place. We also know how to copy, we also know how to make views, all kind of views for that matter. One more big important topic will be all those members we've created, how to adjust their length, how to adapt them, how to cut them, how to modify them. So for this, we have an edit menu next to members. So I often refer to that menu as member edit. And the first function we encounter in there would be length modification. Right mouse click, we'll have a box with several options, and it will be a function to lengthen, shorten. Let's take, for example, 10 inches. OK will be as pick member 2, pick member 3. We can keep going on until we press enter. By the way, we see a counter here that we have 4 components. So members, bolts, and welds. 4 members, 0 bolts, 0 welds selected. Confirm with enter that the selection is done. And then we have to pick the end of the member, either the bottom or the top of the member. So lengthen that side, enter to confirm again. Let's do that once more. Select the members, select the edge. Select the members, select the edge. Right mouse click to call up the box once more. And next up will be adapt. We adapt to plane. That plane can be defined by 1 point or 2, 3 points. We can leave a clearance, meaning a small gap between the adaptation plane or the adaptation plane and the components. OK, several components, enter, 2 points for a plane. Come back, members, enter, 2 points for a plane, enter, and then we can clearly also see the gap. One thing I forgot to mention about the length and shorten, I used a value of 10. Now if I use a value of -10, then it will not lengthen, but it will shorten the member or members. Then adapt to member is a very commonly used function. So I'll leave, for example, a gap of 1/4 of an inch. We're going to adapt to surfaces. OK. This component enters what we call the toolpart, the component that will not change. Enter. This is the component that will change. Enter. And then we have a little gap of 1/4 of an inch. If I want to speed this up a little bit, I could say double click, and we're done. It doesn't matter where I will use this function. I would just double click this, and this is the member we have to adapt. Enter, and it will be adapted. This component adapts the column. I could also use perpendicular on axis. What does that do? Especially useful for bracings, but I could easily also show it over here. This component, enter, forces this one to change, enter. So we'll adjust it to the first contact point with the little gap, of course, but it'll be an orthogonal cut. So it's a bit like lengthening or shortening up to a certain plane. If I, for example, move over to axis 1, we can see that very well with the bracing. Member edit, length modification, adapt to member with a gap. OK, this, enter, forces this, enter. And it will adjust itself to the first, what we could call contact plane. If now I would like to adjust to the external volume, right mouse click, we can switch to external volume. So at this moment, it will consider the column to be a rectangle. Enter, this adjusts to it. So then we're moving the bracing outside of the column. So depending on the situation, you might want one or the other. And then there is also cut. Okay. Let's come back to row A. I could use that over here, for example. Cut 2, 3 points. Okay. This component, enter. This is the adaptation or the cutting plane. Enter. This is the side that falls off. Enter. Do the same thing over here. This is the component. Enter. This is the plane. Enter. This is the side that falls off. Enter. With lengthening, shortening, or adapting, it's always the shortest side that will adjust itself. So it's always the longest part that will remain. With cut, you can define what goes away. It could be the biggest part of the component or not. It depends. If you want to come back or put a member back in its initial status, it's definitely possible. We have this initial state. Okay. Pick one or more components, enter, pick the side that has to come back to initial state, and it will come back. Over here, for example, as well, no matter how many times we modify the components. Then there is also split. I can put a gap in between. Let's exaggerate a little bit. These two split along this line, and it's split up in various components. So if I would like to split up these girts, could split them up like this. And then I'll see we have that gap of 5 inches. If I think, oops, I should not have done that, I want to regroup the components, certainly can. These two, enter, these two, enter, or these two, enter, these two, enter, these two, or these two. The components could also be created separately. So if I were to do something like this and this, they would be, or 3 components, edit, length modification, regroup, 1, 2, and 3. They'll become one component. So as long as the same section in the same position, in line, no problem, components can be regrouped. Another adapt or edit function we use quite a lot is miter. Yes, for example, the 2 rafters, I could both adapt them to the plane like I did earlier, but I could also say miter. There are options for this, depending if we have different size profiles, whether we want the miter on the inside, outside, axis, or in and outside. I'm going to say I need this. I need a clearance of 5. These two, and I'll have a clearance of 5 inches. And then one of the functions we can still have a look at would be the volume modification. That would be to punch one volume with another. But to show this example, I would need a couple more components. So let's create a certain pipe. Like this. 1, 2, 3, 4. Just randomly place these. And then we'd go edit, volume modification. We make sure that we use the full volume of what we call the tool part. Okay. This component does not change, it's the tool part, enter. This one gets adjusted to it, enter. And we can see that the pipe will nicely be cut out. If I decide to have a little clearance, make it visible enough. 1, enter. This one adapts to it, and then we'll have a clearance to it as well. If now you'd like to create a hole inside a component, yes, you could. In the past, we would make a punching volume, so we would make a little block or a plate or a pipe and then punch it through, for example, the web of a beam. But these days, we don't have to do that anymore. We can choose from various shapes over here, round, more like a slot hole, rectangular with roundings, rectangular with corners, hexagon, or just free shape. Let's create a rectangular hole. It has a length of, let's say, for example, 5 inches, a height of 3 inches. We're going to delete the tool part. It goes through the complete depth. We're at the center of that opening, and we would say, let's come back here. This is the location, enter. This is the element we want to punch through, and we just punch a hole. It doesn't matter whether it's correct or not, or whether it makes much sense in this case. In this case, clearly it doesn't, but it would punch right through the component. If now I'd say need an anchor point, but let's say take a free anchor point. So we change our pick mode to free, say in this location, enter that component. There we have the hole. There will be more functions to discover, but we'll go through them at a later stage. These are already the most commonly used, the most basic and most commonly used member editing functions.